So we are moving on to the next method, which is lowest cost entry method. Now in lowest cost entry method, under this method, we choose the lowest cost in the matrix. It's also called matrix minima method. Steps to be followed: 1. Formulate the problem. 2. Determine the lowest cost in the matrix. 3. Allocate the minimum of the row, total, and column. 4. Cross either row total or column total which has been exhausted. Then finally, from the reduced matrix, follow procedure 2, 3, and 4 until you exhaust all the demand and supply. So we use the previous question, which we did under northwest corner method. So we are solving the problem using the lowest cost method, formulating the equation from the problem. So this is the part of the equation whereby we have destination, source. Now this is the equation. So can we now bring down the equation to our formulation? So we have destination and supply, D for destination, S for supply. So we have the source. Our destination is Voi, Chemelil, and Nairobi. Our source is Kapsabet. Kapsabet we have 6, 4, 1. Supply is 50. Busia is 3, 8, 7, which is 40. And then finally Meru is 4, 4, 2, which is a total of supply, which is 60. And then our demand is 20, 95, 35, meaning that the total is giving us 150. So the equation is balanced. So number 1, in the least cost entry method, we need to do number 1, identify the lowest cost. Our lowest cost is 1. So in our 1, we do the allocation. So we do the allocation. Can we allocate the value? So 50 and 35, which one is the lowest? 35. So 35, we do allocation of 35. So meaning Nairobi has been exhausted. This column has been exhausted, so the remaining is 15. So we take the reduced matrix. Our reduced matrix is Voi and Gemelin, and then supply. We still have Kapsabet, Busia, and Meru, whereby we have 6, 4, 3, 8, 4, 4. The supply is 15, 40, and 60. And then our demand is 20 and 95. Again, we look at the least cost. Our least cost is 3. So being 3, we do allocation. We allocate for 3. 20 and 40. Which one is the least? 20. We take 20. We allocate 20 to Busia. So Busia already has been exhausted. Not Busia. 20. Voi has been exhausted. So what is remaining? 20. So the reduced matrix, we are remaining only with Chemelin. In the destination, Kapsabet for source, Busia. Yes, Busia and Meru, which is 4, 8, 4. The total is 95. Yes, the total is 95. We have supply is 15, 20, and 60. Now, we do allocation. Definitely, we don't even need to look for the list. we just take direct amount. So allocation for the first column is 15, second one is 20, the third one is 60. So this brings us to the allocation. So meaning which cells have been occupied. So the cells which have allocation is C12, which is here, and then another cell is here, C21. Another cell which has been occupied is C13, C23, then C33. What are the values? The value for C11 is 35 times 1. The value for C21 is 20 times 3. The value for C13 is 15 times 4. The value for C23 is 20 times 8. And the value for C33 is 60 times 4. Now, when you say 35 times 1, gives you 35. 20 times 3, 60. 15 times 4 gives you 60. 20 times 8, 120. 60 times 4, 240. So when you total this, gives you what? 120 plus, no, this is 20 times 160. Sorry, it's supposed to be 160. So you get 400, you get shillings 555. That is the total. So in our lowest cost entry method, the lowest cost for transporting a material from one point to another is costing us 555 shillings. Now looking at our slide, we can attest to that. We have 6 times 35 plus 3 times 20 plus 8 times 20, which is giving us 555. Thank you so much for your